what is the function here? I see if I was in the, fifth grade, I would approximate this with 9 over square root of 2 times 2. Wouldn't you? So that's my fifth grade intuition. But this is asking me to do linear approximation. Now, if it's a linear approximation, I need to have a function. When I was trying to do my intuition for fifth grade, I unintentionally changed 3 numbers. Which are the 3 numbers? 1, 2, or the other way around? 3, 2, 1, right? Those are the 3 numbers that I changed. So those are things that are varying. So those are the variables. So what I do is I write x, y, z, and then I have x on top, whichever order you go, y, z. So that's the function that I'm using basically, that's the function, and I'm trying to approximate this function by linear approximation. Because that's the function that if I plug in 9.02, 2.01, and 1.99, I get the answer for that expression. So I always talk about anchor point. Anchor point is the one that you're approximating at, approximating with. I'm using points 9, 2, and 2. And then the points that you're approximating, you're doing the approximation for. So this is going to be my A, B, and C in the linear approximation. Then the points that you're approximating at is 9.02, 2.01, 1.99. Okay. Linear approximation is just the tangential plane, right? It's, in this case, it's a hypertangential plane. So what do I do? Gradient of f, f sub x, f sub y, f sub z. I'm not putting the inputs in because it's going to take a long time. F sub x is what? Derivative of that with respect to x is just 1 over square root of yz is a constant. 1 over square root of yz is just a constant. Then derivative of x, which is 1. Then let's write this in a different format. X, y to power -1/2, z to power -1/2. Now take the derivative of that with respect to y. These two are constants. And I will have -1/2 here, and y to power -3/2. Now take the derivative of that with respect to z, partial respect to z. These two are constant. And -1/2, z to power -3/2. Now, having those, what I need to do is I have to evaluate gradient of f at the anchor point. Okay. So for plug in y and z equal to 2, and I get 1/2. Plug in x9, y and z equal to 2. I get x is 9. Z 2 to power -1/2, 2 to power -3/2. That's 2 to power -4/2. That's 2 to power -2. Did I do it right? So negative 9 over 8. And then same thing here. I will get negative 9 over 8. So I have those basically. So linear approximation at 9, 2, 2 of x, y, z is going to be equal to 1/2 times x minus 9 minus 9/2 y minus 2 minus 9/2 z minus 2 plus w, or I guess d. What is w? W is the output of the function. So if you plug in 9, 2, 2 in here, you end up with 9/2. The w is 9 divided by square root of 2, 2 equal to 9/2. Are you guys with me? Should I go over this one more time? Now that we're with this point, now plug in what you have. L9, 2, 2, 9.02, 2.01, 1.99, and I get 1/2. I don't need to really, I just have to remember 9.02 minus 9 is 0.02 minus 9/8. 2.01 minus 2 is 0.01. And then minus 9/8. And 1.99 minus 2 is minus 0.1. Sorry, minus 0.01 plus 9/2. And you get the answer out of that, which is what, 0.01. And these two simplify each other, plus 9/2, which is 4.5, approximately. So the linear approximation, let me write this down and I start a new problem. Is approximately that. Okay, questions? Yes. Tell me. You want it down or up? This is okay. Okay, Zoom. Do you guys have questions? I'm just